Hello everybody, and welcome to this demo session about Ansible and Terraform on public cloud. My name is Johan Lamoureux. I'm Solution Architect at OVHCloud. I'm quite sure you already heard about infra-as-code and more often about the tools which are used in this context, like Puppet, Chef, Ansible, and Terraform. Today, let's focus on both of them, Ansible and Terraform. First, a short recap on these two tools. Terraform is agentless, meaning you do not require to install something on the resource you want to manage. It only uses available APIs. Stateful means it keeps a status on deploy resources and is able to compute the difference and apply only the required changes. It's based on providers who implement datasets and resource creation. And all of the core on the providers are written in Golang, meaning Terraform is cross-platform, can be used on Linux, macOS, and even Windows. On the other side, Ansible is independent. It means you do the same operation each time you run your deployment code. It's agentless, no need to have any agent installed on resource you manage too. But in fact, it will sometimes need some Python code or available if no API is available. It's stateless, meaning as Ansible is independent, you don't need to keep a status on resources managed. It's also based on module and sees the 2.10 versions implement collection with regroup modules. All the core and modules of Ansible are written in Python, meaning Ansible can only run on Linux and macOS right now. Now let's consider OVH Public Cloud, on which we would like to deploy our great and awesome new application. Public Cloud of OVHCloud is based on OpenStack, meaning we have Nova for the compute, Neutron for the network, Cinder for the block storage, Glance, image, and so on. As OVHCloud, we provide the standard API. That means we give you direct access to the Keystone v2 for the authentication, and for each region, the different components APIs. If you know well Ansible and Terraform, I'm sure you notice there is no public cloud modules or providers. It's because at OVHCloud, we do not reinvent the wheel. In both Ansible and Terraform, it exists an OpenStack integration to deploy workload and manage resources. Let's see how to use them on public cloud. So on the right, we have the Horizon interfaces, so GUI from OpenStack. And on the left, a shell with the Ansible installed on Terraform on the boxes. Start with Ansible. We have several playbooks to deploy our resources. First of all, 0.1. So, because we will interact directly with the APIs, we don't need to deploy or have any connection outside of our local host. First of all, we have some variables that I will show you later, and we have the environment. These environment variables are all the information to be able to connect to OpenStack backend with the authentication URLs, the different tenant name, region ID, username, and also password. Then we have several resources to deploy our workload. First, we use the OS_keeper to push our keepers to be able to boot VMs and set up the SSH connection. Then we will create some security group, one for the admin plan, the other for the application. And then in the security group, we will set up some security rules to allow only our management plane to be able to connect and expose the 80 ports, the HTTP ports, on the application. We will also create later a backend on the famous private network at OVH called VRAC with a segment ID, so VLAN ID 0, so no VLAN. We will also assign to this network a subnet to be able to provide IP address for the different boxes. Let's see what we have on the variables. On this, we'll see some information. So the keeper name, the flavor we would like to use for deploying the VM, the images, so it's based on Ubuntu 2004. We'll also have the front numbers, and I also keep information about authentication if I need it. Now, let's see what happens when I run the first playbook. Normally, you don't see some changing on this, only on the key pairs. So key pairs demo has been created, and also all the aspects on the network. On the next playbook, also we find again the different variable and environment information, and then we move to create some instances. So we use for that the OS server modules. We set as present, we name our images or instances, sorry. Then we define or we reuse from the variable the different information like the image name, the key pair previously created, the flavors. We define also the attachment of the interface of the instances to two different networks, the external network and the backend previously created on the VRAM. And we also push some users data for the cloud inits. For example, installing Ansible in the boxes, do the upgrade of the package, adding some SSH and configure the networks. Let's run this playbook. So you have noticed a warning about the inventory because we only consume localhost. There is no other resources reference in the inventory. As you could see, we already have the Bastion instances on the inventory with a task of spawning when the OpenStack has launched the deployment and it's not running. Now let's move to the next step. We'll deploy instances called DB. The main goal of these instances is to, for example, host our DB servers for the application. Again, we reuse the image information, the key pair flavors, but we only connect this instance to the backend network we previously created. Let's see now. Step. We deploy another instances called front to deploy our application. On this playbook, we deploy an Oasis server also, with the tunics, means public networks, but also the backend, and we'll assign the security group called My Applications. We also define some user data for the cloud init configuration with some package, network configuration, and so on. Let's run this playbook. Okay, so the instance has appeared. Is it in spawning states, and the two networks have raised. Okay. The two networks get an IP address, and it's done. So now we have a Bastion instances, a front instances, both connected to the public network and both protected with a security group, and with a backend network on VRAC to be able to communicate both together directly and in a secure way without consuming the public networks. So we are finished for the Ansible demo on OpenStack. Before jumping to the Terraform, we need to clean up our environment. And for doing this, let's call a playbook called cleanup. Again, on this playbook, we find again our environment and var files. We have several modules, also previously called, so the OS servers. If we have some, we delete it. We have also the Bastion to remove, so that is absence. And we also clean up our environment, means the key pairs is removed, the security group is removed, and the same for the network and the subnets. Let's try it. Understand. You can confirm that no instance there, and also keeper is no longer on the environment. And it's done for Ansible. Now let's try to reproduce this with Terraform. So Terraform has another way to organize different resources. So we have to call providers. So the providers on Terraform is called OpenStack, and we define again all the information. So the tenant ID, the URLs, the region on where we would like to deploy the workload, username, and passwords. Now let's see which kind of information we need. So I define some variables. So for example, accounts on the front instances, the keeper path, the image value. So by default, if I get precise or overwrite this value, it will choose the Ubuntu 18.04 and the flavors also. I have defined specific to the application values. So I choose to deploy only one front instances. I choose the most updated images, Ubuntu 20.04, and the two keepers. Now let's see the data we need to extract from OpenStack. So based on the flavor, image name, and so on, OpenStack will compute this information to find the right ID to manipulate the resources. It's the same for the external networks. After having all of this, let's look at resources. So first of all, we will create or push the demo keepers based on the name of the local boxes. Then we will create a security group called Bastion. And we define some security rules on these security groups. It's the same, we do the same, for the application. So my application, we create the security group and define some security rules on it. So for example, for the application, we allow any client or any connection on the HTTP port, so 80 ports. And we also allow the outside communication from the application. After that, we will create a private network or OpenStack network with the VPN at OVH called VRAC and with segment ID, which is the VLAN ID. So all the communication on OpenStack can be extended to any other compatible product at OVHCloud. Maybe if you would like to mix, for example, public cloud with private cloud Baremetal and so on. On this OpenStack network, we will also assign a subnet to provide the IP address on the instances. We also indicate data for the cloud inits for the different boxes, and then we'll move to deploy the different instances. So the first instances will be called Bastion. We reuse the image. We will extract image ID, flavor ID, and keeper from the previous data set extracted. We'll push in the user data all the cloud information. The two networks for the external and the backend, and also a capability to connect to the instance to do for additional provisioning. For example, checking the cloud init status to be sure that the provisioning is done and continue. In the same steps, a DB instance will be created, but these DB instances will only connected to the backend networks, so not accessible through internet. That's why it's only connected to one network aspect. And the last instance is called fronts. We use accounts. That means we will be able to deploy multiple front instances to, for example, scale the application, define the security group, define the user data for the cloud provisioning, two network, front, the external network for the public access, and the backend network to be able to connect to the DB instances. Also, we define the connection on this instance and tracking the different aspects of like checking the cloud init status to be sure that at the end, all the pricing is done. Let's see now what are the contexts. Oops. We need first from init. We need to initialize the context by downloading the different providers. So as you can see, we download the OpenStack tip providers. When it's initialized, we could plan and see what is planned to be deployed on our OVHCloud. So if I look back, I will find all I'm previously talking about, security role, etc., etc. So at the end, we'll see 15 resources will be deployed. So let's apply this deployment plan. Sorry. So therefore, we'll call again the context to see what change is needed, and also require confirmation to apply this change. And so we'll see the instance, the keeper demo is now existing. We'll also see in the instance the 3 instances are in spawning, mean Terraform will parallelize the deployment to speed up the process. You can notice that the DB has already an IP from the private subnet located, and all is done. So now we have a bastion, a job host to manage our platforms or application. We have a DB where we are able to deploy, for example, our MySQL instances for the application, and a front instances to be able to expose our website. Now, if I would like to scale my platform, let's change the font counts to 2. Okay. Now, code again Terraform to see what change are needed. So, as Terraform keep the previous deployment states, you know that it only needs to create an additional front instance. So that's why on resources, just say 1 to add. And if I apply, it will compute the front instance name and create them. So the front one is on the spawning states, and it's done right now. So we have deployed our additional front to be able to scale the platform. So before leaving this demo, I will clean up my environment, like, restoring the previous states. For doing that, with Terraform, we could call the destroy command. So when we call this destroy, it will list all the existing resources previously deployed. And it have to destroy 16. So the first 15 resources and the additional one we add later. So if I confirm, and I will confirm, it will remove all these resources and restore the environment to the previous states, or initial states. Sorry. So the instances already disappeared, and the key pairs no longer exist. And it's done. Thank you for joining this demo session. We are available through the chat for any question. Have a good day. Bye-bye.